Okay, we're on to number 6. Number 6 has a tennis ball. The mass of the tennis ball is 0.058 kilograms because it's in grams and I can't leave it like that. The tennis ball is going to get served, so it's going to start with an initial speed of 0. Its final speed is going to be 45. And this impact gives the ball a constant acceleration over a distance of 44 centimeters, so I have to put that in meters. And they want to know what force is being delivered by the racket. Well, the racket is pushing the ball in the direction of 45 meters per second, which I'll call positive. So I need to get my acceleration, Vf squared minus Vi squared over 2d. Vf is 45. Vi was 0. D was 44 centimeters or 0.44 meters. So I did my math, and when I did my math, I got my acceleration to be 2,301 meters per second squared. Now I want to do the force, because that's what they're asking me about. Net F is equal to ma. The mass is 0.058 kilograms. The acceleration is 2,301 meters per second squared. And if net F equals ma, when I multiply to m times a, I got my net force to be 133 newtons. Okay, number 7 talks about during a circus performance, a 72 kilogram human cannonball. So let's write that down. So the mass is 72.0 kilograms. And it's coming out of a cannon 18 meters long. And the time in the barrel of the cannon is 0.95 seconds. And what else do I know? That looks like it. So what I said was, well, I know that he's going to start with an initial speed of 0. So I can say d is equal to 1/2 at squared plus vit. The distance is going to be 18 meters. I'm looking for the acceleration, so 2d over t squared should give me a. So a is going to be equal to 2 times 18 meters over 0.95 seconds squared. Don't forget to square it. So when I did that math, I got the acceleration to be 39.9 meters per second squared. And then they wanted the force, so I said, well, net F is still equal to ma. Mass is 72 kilograms. Acceleration is 39.9. So the net F that I got when I did that was 2,870 newtons. All right. Number 8. Okay, number 8, you had a rock of 45 kilograms, so the mass is 45 kilograms. Breaks loose and falls to the earth, but there's air resistance, so that force of air resistance is going to be 250 newtons. And they want to know the acceleration of the rock, just like number 7 from the other exercise we did. So here's my rock. mg is pulling down. Resistance, air resistance is 250. So my weight is mg. So that's 45 kilograms times 9.8 meters per second squared. I'm going to let this be positive and this be negative. They just need to be in opposite directions, one positive, one negative. So if net F equals ma, then I have the weight minus the force of resistance is equal to ma. So the weight is 45 kilograms times 9.8 meters per second squared. My resisting force is 250 newtons, and it's negative because I picked that to be the direction of negative. My mass is still 45 kilograms. And I'm looking for my acceleration. Oops, that's a goofy looking A. Alright, so when I did that math, I got my acceleration to be a positive 4.24 meters per second squared, which means it's accelerating toward the Earth, but not at the rate of gravity because there's some resisting force, so that's the acceleration. Alright, number 9 is kind of long. So I'm going to stop this and then I'll come back and do number 9.